Hi, my name is Mr. D, and today I want to take a look at evaluating definite integrals. So we have evaluate the definite integral from 0 to pi over 4 of 1 plus cosine squared theta divided by cosine squared theta d theta. So for a problem of this type, whenever we see cosine squared, it's tempting to want to substitute for 1 minus sine squared. But as we're going to see in this example, we can make this a lot easier just by making an algebraic manipulation. So if we could call the beginning of the problem step 1, for step 2, what we want to do is we want to break this apart into two integrals. So we're looking at the integral from 0 to pi over 4, and now we're going to break this fraction apart into two fractions. So we could separate it as 1 over cosine squared theta d theta plus the integral from 0 to pi over 4 of cosine squared theta divided by cosine squared theta d theta. So notice all that we did was separate the numerator into two pieces. We have 1 over cosine squared theta plus cosine squared theta over cosine squared theta. What this allows us to do, though, is simplify each integral. These are much easier to integrate now. So we look at the first piece, we'll call this step 3, and we're looking at the integral from 0 to pi over 4. I'll just write this a little bit higher up. So the integral from 0 to pi over 4 of 1 over cosine squared theta d theta. Well, notice that 1 over cosine squared theta could be written as secant squared theta d theta. So all we did was just rewrite this using our reciprocal function secant. And now we have plus the integral from 0 to pi over 4. But notice that cosine squared theta divided by cosine squared theta is equal to 1. So we could just rewrite the second integral as d theta. So you can think of there as being a 1 in front of the d theta, but cosine squared over cosine squared just simply cancels out. So now for the next line, we could integrate each of these. The antiderivative of secant squared is tangent. So for the first integral, the antiderivative is the tangent of theta. Plus, the antiderivative of 1 with respect to theta would just be theta. And now we could set up our bounds from pi over 4. Well, pi over 4 is our upper limit, 0 is our lower limit. All we're doing here is applying the fundamental theorem of calculus. We find the antiderivative of each piece, but now we need to evaluate it at the upper limit and the lower limit, and then subtract the two. So then for the next line, step 5, we're evaluating tan theta plus theta at pi over 4. So we could throw on parentheses, we have tangent at pi over 4 plus, and now we can replace theta once again with pi over 4. All we're doing is substituting theta with pi over 4 for the first part, and we're subtracting, and now we substitute theta with 0. We have tangent at 0 plus 0. So now looking at this, we could simplify, and we'll call this our step 6. Tangent at pi over 4 is equal to 1 plus pi over 4. And now we're subtracting tangent of 0 is equal to 0 plus 0. So really our final answer will be 1 plus pi over 4 minus 0. So our answer to this problem, we have 1 plus pi over 4, which is going to be our final answer to evaluating this definite integral here. Okay, well, this is going to conclude this evaluating a definite integral problem. Thank you all for watching, and I hope that this was helpful.